In this video, we're going to explore basic data analysis methods. We're going to cover data types, functions, and data visualizations. I've pre-written some of the commands here in my R script file so that I can just run through them easily. So first, R has a wide variety of data types, including vectors, matrices, data frames, and lists. We're going to talk in detail about the two most common ones, which are vectors and data types. So vectors are one-dimensional arrays, which is an index-based data type that can hold either numeric data, character data, or logical data. To form a vector, we're going to use the combine function C parentheses. Here are examples of each type of vector. I can store different numbers in a vector A. I can store actual strings of the numbers in vector B, and I can store Boolean values, true, false, true, true, in another vector. So if I just run this chunk of code, we can see that it's stored in our global environment, and I can return A, B, and C, and have R return the values of that to me. You can refer to elements of a vector using a numeric vector of positions within brackets. For example, A of 3 refers to the third element of vector A, so let's run that. You can see it returns 5. And vector A combined to 4 refers to the second and fourth element of vector A. So let's run that, and you can see it returns 4 and 3, which is the second and fourth index of the vector. Moving on to data frames, a data frame is more general than a vector. It is similar to data sets you typically see in other data analysis tools. It can contain different types of data, numeric, character, and logical, just like a vector, and data frames are the most common data structure you'll deal with in R. So let's give an example. Let's create a data frame about patients. So I have to create all the individual vectors first. So I have my patient ID numbers, the age of my patient, diabetes type, status, and the glucose levels. So after creating all these individual vectors, I need to put all that into my data frame, and I'm going to use the data frame function and store that into my patient data variable. So let's just run this chunk. You can see that I now have patient data. It has 4 observations of 5 variables. There are several ways to identify the elements of a data frame. You can use the subscript notation, or you can specify column names. Using the patient data frame, these examples are some of the approaches that you can use. So I can do patient data 1:3, and that will return columns 1, 2, 3 of my data frame. If I do patient data and combine the vectors age and status, it only returns the columns age and status. If I do patient data dollar notation age, it returns the age vector. This example is used to indicate a particular variable from a given data frame. For example, if you want to cross-tabulate diabetes types by status, you can use this following line. Table patient data $sign diabetes, patient data $sign status. And if we run that, we'll get a cross-tabulation of diabetes type by status, as expected. Now, let's move on to functions. Now that you have all the data structures, we want to play around and manipulate the data. As a data analyst, you're typically faced with data that comes to you from a variety of sources and in a variety of formats. Your task is to import the data into your tools, analyze the data, and report on the results. R thankfully provides a wide range of tools for this. Almost everything can be done through functions. A function is a piece of code written to carry out a specified task, and it may accept arguments or parameters or not, and it may return one or more values or not. So in R, a function is defined with the construct function, argument, and then your body. We're going to use most of the built-in functions in R, So the only thing you need to worry about is how to effectively communicate the correct input arguments and manage the return values. To give an example, R provides a wide range of functions for obtaining summary statistics. One way to get descriptive statistics is to use the sapply function with a specified summary statistic. It applies the function to every value in the vector. So for example, here I have function x plus 10, which means I want to apply the function x plus 10 onto every index of the vector age. So let's just give this a run, and you can see that the age previously was 25, 34, 28, 52, and now it's 35, 44, 38, 62. Other possible functions that you can use as examples are standard deviation, variation, min, max, median, range, etc. To give an overview of the patient data's statistics, you can just say summary and put the name of the data frame in the parentheses, and you'll get a very brief summary of each variable. Doing this can help you catch errors in the data or just use the numbers for analysis. I find this very helpful when you're trying to just start your data analysis process. And finally, we're going to talk about data visualizations. In R, graphs are typically created interactively. So one example of that is we're going to use a pre-made data set on motor trend car tests, which is MT cars, and we want to attach that. And then we're going to plot weight against miles per gallon. And then we can plot a regression line and then add a title of regression of MPG on weight. So you can see here the plot pops up on the bottom right corner and is super simple. You just have to plot your variables, add a regression line, and add details in later. Now R is most famous for high quality visualizations. So the most common of all plots is the scatter plot, which is used for exploring the relationships between two continuous variables. The patient data frame that we used before has a really good example. Let's start by asking, does age affect blood glucose levels? So the first thing we need to do is use a plot function. So we're going to plot age with glucose and use that with the patient data frame. So let's run that. And you can see we have the 4 different values plotted on the right hand side, and there seems to be a correlation, but we don't know yet. Now, to have a clearer view of it, plot allows for customizing your output and changing colors, etc. So just to give an example, I'm going to change the color of the variable dots to violet and have it be filled, just so it is more visually pleasing. So now that it stands out, we can see that there is a positive correlation between age and blood glucose level. This is just one simple example, and you can find lots of other resources online on more advanced data visualization methods, and there's a lot of built-in functions that will help you with that. And that's it. I hope this was helpful for getting started in R and learning the basics. I recommend pausing the screencast and trying out the commands yourself and play around with existing dataset packages in R, and then practicing on a mini project yourself.